just a few words about the négaWatt Association before I get into the contents. As you already said, it's a think tank on energy issues, mostly, but not only working on sufficiency, which was created almost 20 years ago. And it has worked a lot on building scenarios, long-term scenarios for bringing them in the front debate and raising issues and raising issues about getting to a sustainable energy system and raising sufficiency as an issue, as something to be addressed through policies for all those years. And I've been an active member myself for more than 15 years now, and I'm nowadays both one of the spokesperson and the head of prospective analysis, which means I'm kind of coordinating the work we are doing in building scenarios, mostly on the methodological side. So, sufficiency to us is really part of a kind of pragmatic approach we try to develop to address what we see as a very systemic issue, which is the unsustainability of the energy system, and through the energy system of the whole production and consumption modes, since the energy system, of course, is completely framing our society from an economic or social perspective. And we think that to get to a more sustainable system, we need to shift to substitute resources, substitute more sustainable resources to less sustainable ones. And that starts with reducing the amount of resources we need, which of course deals with efficiency. That is an important part of it, reducing the losses all along the energy chains, but which really should start with thinking about energy services and the way they are delivered and the reasons why they are delivered. So being smarter and designing energy services is really the starting point of our whole approach. We see sufficiency really as a key enabler of energy transition. First and mostly as a kind of accelerator of substitution, as I already addressed, but also as a way to bring positive co-benefits that are very important regarding land use, the use of raw materials, and or health impacts, for instance, and also as a way to increase, and that is obviously an important topic given the crisis we are going through, building more socioeconomic resilience through reducing our vulnerability to shocks and sensitivity to consequences of such shocks. We also, altogether, we think sufficiency as part of reducing energy demand or mitigating energy demand is an important component of sustainability as a whole, and not only from the carbon neutrality and climate change perspective. This graph is taken from the work that the IPCC did as part of its 1.5 degrees special report, where it conducted a review of scientific literature regarding the impact of each of 23 main options for reducing greenhouse gas emissions on the 16 other sustainable goals. That would call for a lot of details to be discussed, but the overall lesson from that analysis is that when you look at the score or the impact of many options on the whole set of sustainable development goals, the options that call for reducing demand, and particularly those that relate to behavior change, rate very high in that scoring. when we think of sufficiency, and that brings us further to the issue of how we should model sufficiency and address it in building scenarios. We came through the work we've done on the issue to really identifying and distinguishing different levels of sufficiency, which actually relate to different levels of actions or call for different level of organization. I mean, starting from those that are the most end-use changes to those that are more collective and over the long term. We make a distinction between what we call servicial sufficiency, which relates to the intensity and duration of use of equipments, which even goes for very basic things like shutting down appliances to reducing speeds on roads and so on. Then a level that we call dimensional, which relates to the size, the nominal capacity of equipments, and this gets into more deeper and more important issues, such as the evolution of the size of dwellings, or the evolution of the size of cars that could go together with shifting from the kind of proprietary model we used to a more servicial model, where we would get access to different cars of the right size for different purposes. And the last level is the more organizational one, where we should address sharing of equipment, sharing of co-working places, sharing of cars, for instance, or collective transport, but also collective planning, such as urban planning, to try to shift from past tendencies, distances we need to cover to go from houses to working places, for instance. We, of course, include in our approach the sufficiency on other resources than directly than energy in a direct way, and that calls for sufficiency on other goods and food, change in diet, reducing packaging and things like that. The reason why we try to address sufficiency, like the other issues or the other leverages of energy transition through scenario, is really that we think change can only happen if we set all together a long-term vision that is appealing enough. If we get an idea of how to get there, so we need to building a step-by-step pathway that is concrete and consistent, and also, of course, building a scenario is a way to think, discuss, and design policies and measures. So that is really why we've been working on scenarios from the beginning and working on including sufficiency in our scenarios. The way we have developed our modeling is very simple, straightforward, and very physically based. We going from the right to the left. We start with energy uses and therefore energy services, and get back through energy chains to efficiency and sufficiency that could be developed in the different sectors, changes in energy carriers, and finally the need for primary resources and the substitution that can happen there. And of course, once we've developed this modeling of physically sound and realistic pathway, then we develop some assessment of environmental impacts, mostly greenhouse gas emissions, but we also have complete assessment of the use of raw materials in the French economy, and some economic assessment, mostly on costs and investments and jobs. This is an illustration of the way we try to represent the complete energy chains for the purpose of our modeling. So apologies because I don't have this one in English, but again, we start from the right, and we start from describing the needs of the population, in that case in the building sector, in the residential sector. And you can see, and I won't get into the detail of the rest of the of this scheme, but you can see on the right that we really start with the average surfaces of dwellings, the number of dwellings, the number of people per dwellings, and that means we can change this in the model. We can bring assumptions about this kind of indicators in our model. This is just to show that I mean, once we introduce sufficiency assumptions, that has an impact, of course, on the overall pathway, on the balance between carriers and so on. That has an impact on key outputs, and we work through a kind of iterative way to adjust assumptions depending on the impacts on the balance and the environmental outputs. Yeah, well, this is a bit redundant with things I've already said, but I mean, we really try to see sufficiency in an integrated way as part of an overall broader energy conservation focus. So we distinguish between the leverages or levels of sufficiency, as I already discussed, and the levels of efficiency in energy transformation chains. And we include, of course, the concern for life cycle energy, the gray energy that is used in building appliances and manufacturing appliances and building houses and so on. This, and again, this is not about getting into the details, but just showing again the way things combine in our physical modeling, and the way we identify energy sufficiency levels in the process. Like in that case, for transports, model share the number of passenger kilometers, or the occupancy rate of vehicles, or road speeds evolution. And then for each of these levels, we can get into more details about indicators like transport mode or person kilometers, and levels like the number of telework days, or the distance covered through the density, through changes in the urban or rural density, and so on. So we just try to get into details, identify indicators, identify levels, and that both helps us to building and justifying consistent sufficiency assumptions, and of course to think in parallel about policies and measures that would be able, or that would be needed, to address the kind of change that we include in our assumptions. This, and I won't further comment it. I mean, it's just for the sake of keeping it in the presentation. It's just showing the same process for the residential sector. I mean, taking into account the building stock and so on, for instance. So again, in the building sector, we can identify sufficiency levels, and then get into details of indicators and levels that would have an influence on this on the energy service indicator that we have chosen in the model. Coming now to the way we, I mean, to the overall impact of the sufficiency in our modeling and in our scenario. This is just about the overall results of the scenario, which is a pathway towards 100% renewable energy supply for France through, as you can see, the implementation of efficiency and sufficiency. It says increased because that is on top of the current policies and measures, which is the dotted line on the top. I mean, we have shown through this scenario and the previous one in 2011 that this brings not only 100% renewable, but of course it delivers on climate objectives. Our scenario in 2017 was the first to propose a net zero pathway for France by 2050. We show through the modeling other environmental benefits like reduction of air pollution or reduction of the raw materials footprint, and we also show some socioeconomic benefits like the creation of jobs or more social justice, for instance, like reducing energy poverty. The way we model in a very bottom-up and physical way the change in the energy system allows for us to kind of account for the respective role of sufficiency and efficiency in reducing energy demand. And you can see here that the increased reduction in our scenario compared to the existing policies and measures mostly come from further sufficiency in transports and industry, while in buildings the most important part is the complete and deep thermal retrofitting of buildings, therefore the share of efficiency. But I mean, it's not very obvious to get to that kind of accounting, and we've had some problems, and we have not completely solved them, but we are trying to do so. In some cases, like like this example, which deals with specific electricity in the residential and tertiary sector, it's quite straightforward with the way we build assumptions to identify the role of sufficiency in reducing demand, but it's not always that obvious. And one of the issues we have is that I mean, as we can separate the role of sufficiency and the role of efficiency assumptions in our modeling and our computing, we can distinguish between both. But if you look at them as consequential things, I mean, the weight of the respective weight of sufficiency and efficiency really depends on which you account for first. In that example, we start with sufficiency, and this gives a lot more weight to efficiency in the second place. And you can see that if we, in the same example, again, not getting into the details of numbers, but if we account for efficiency first and sufficiency in second, then the respective weight of efficiency and sufficiency is completely modified. And therefore, we've shifted from that kind of straightforward but biased method to another method, which is trying to bring more refined weighing between the role of sufficiency and efficiency, as if they act in a combined way and not subsequent one, which is actually what happens, of course, in real life. One thing we gain from our experience is that it's actually more difficult, more challenging to develop sufficiency assumption than energy efficiency ones. And there is this idea that when it's efficiency, it's completely technical. When it's sufficiency, it's societal, so it's more difficult, more. It's soft and not hard, and so on. We we are not convinced by that. We think, on the contrary, that there are some technical and societal issues, both with implementing efficiency and sufficiency, and that at the end of the day, building sufficiency assumptions is not that much different from building energy efficiency assumptions, and we can bring ground for that. The issue is more than there is not as much available data and more cultural resistance to developing such assumptions. Well, I'm going to skip that one for saving some time, and commenting very briefly on that one, which is that, yeah, we can really identify through experience the way these different obstacles to building or justifying sufficiency assumptions, whether it's the lack of material, statistical data or supporting the literature, or whether it's individual, societal, or economic representations. These obstacles are always there, but the way they are playing against building sufficiency assumptions is really depending on the kind of assumptions you're trying to develop, whether you touch social values or things like that. So, there's of course a lot of discussion going on about this, but we've had our experience, and it helps in building and justifying our sufficiency assumptions. Of course, we also we are also trying to be part of the overall discussion on the relationship between sufficiency and socioeconomic change, relationship between sufficiency and growth, and we've been trapped for a while in this in this kind of situation where we were just labeled as degrowth people, and we've gone over that, and we really talk more today about thinking of new business models to create value through saving resources. That goes with shifting to a service-based economy, regulation and innovation that is needed for allowing such a shift. And altogether, when we come to kind of justifying sufficiency through the interrogation of needs, individual needs, collective limits, the idea of sufficiency corridors, and so on, and linking this to social justice, we also come to really call for sufficiency supply policies, which means that it's not on the shoulders of consumers alone to change behavior, but it's really on the shoulders of policymakers, of public services, of companies to change the models, change the regulations for that kind of change to happen. And this is very inspiring in the way we are trying also to frame and justify policies. Just a quick word to say that I've talked about the work we've done on the French level. We are now developing a European scenario based on the same idea, same principles, on a bottom-up approach with a lot of partners in different countries. And this brings us to the need to define final energy use targets on a national level, and bringing this discussion on the European level, where we start with very different situations regarding the average wealth and the average energy consumptions, really also helps us in building that thinking and discussion on elaborating final energy use corridors that fit between individual needs and collective limits. And that is my conclusion. I mean, there's a conclusion slide, but you can skip it. Thank you.